Europe's car industry was built on lies, smoke, and noise. These engines were called efficient, clean, and revolutionary, but behind the numbers were shortcuts, cover-ups, and one of the biggest scandals in automotive history. This is the story of the engines that powered a continent and nearly brought it to the ground. The Volkswagen air-cooled flat-4 engine started with a simple idea: build something cheap, build something strong, build something anyone could fix. Back in 1936, Ferdinand Porsche was working on a car for everyday people in Germany. He wanted an engine that could last through rough roads and hard winters. He took inspiration from Tatra's flat-4 design and came up with something different, something simple, something tough. At first, it didn't work out. Zundap, a company Porsche pitched the idea to, said no. They wanted a more complex 5-cylinder engine. Porsche's design was put on hold. Then the war ended and everything changed. In 1945, a British officer named Ivan Hurst arrived at a damaged Volkswagen factory. He saw Porsche's engine and knew it had potential. By early 1946, Volkswagen was making about 1,000 vehicles every month with it. The engine itself was clever. 4 cylinders sat flat in a boxer layout. The pistons and cylinder heads were made from aluminum alloy. The crankcase was magnesium. The crankshaft and connecting rods were forged steel. It didn't use water for cooling. Instead, a fan pushed air through ducts to keep everything from overheating. One camshaft powered both sides of the engine. The first version had 1,131 cc and made 25 horsepower. That was enough to get the Beetle moving and keep it running for years. As time went on, the engine kept getting better. In 1954, Volkswagen increased the size to 1,192 cc. That gave it 30 horsepower. A year later, they added the now famous twin tailpipes. By 1957, it made 34 horsepower and came with a smoother all-synchro mesh gearbox. Volkswagen kept upgrading it. There were 1,300cc, 1,500cc, and eventually 1,600cc versions. In 1971, they added a dual-port intake system to boost performance. For the larger 411 and 412 models, Volkswagen built a version with fuel injection. That engine reached 1.8 liters and made 85 horsepower by 1973. But this engine did more than power Volkswagens. It powered a movement. It was used in the Beetle, the Bus, the Type 3, and the Type 4. In the 1960s, people started building beach buggies using it. Then came the kit cars in the 1980s. You could find it everywhere, even in airplanes. It was light and air-cooled, so it worked well in the sky. Some aircraft versions reached speeds of more than 160 miles per hour. The engine's sound became part of the culture. You could hear a Beetle coming before you saw it. It wasn't fast, but it was dependable. It just kept going. And when something went wrong, most people could fix it in their driveway. The end came slowly. The last Beetle with the air-cooled flat-4 left the factory in Puebla, Mexico in July 2003. The final engine rolled off the line in Sao Paulo, Brazil on December 23, 2005. It was installed in a Type 2 microbus. And that was the end of a run that lasted 70 years. From 1936 to 2006, this one engine changed the world. It gave people their first taste of freedom on the road. It made cars affordable, it made repair simple, and it created a community of drivers and tinkerers who still kept them alive today. It didn't need to be fast, it just needed to work. And it did, for millions of people, for 70 years straight. In 1985, Fiat launched something that didn't just improve engines, it changed how they were made. It was called the FIRE engine. That stood for Fully Integrated Robotized Engine. It was the first engine in the world designed entirely by a computer. At the time, most engines were still being drawn by hand on paper. Fiat went digital. That was a huge leap forward. This engine wasn't just about high-tech design, it was also about high-tech production. Fiat worked with PSA Peugeot Citroën to bring it to life. The result was a smaller, simpler engine that took less time to build. Earlier Fiat engines had around 6,700 parts. The FIRE engine used only about 4,500. That meant fewer things could go wrong. It also made the engine cheaper and easier to fix. Even the build time dropped fast. Older engines took almost 2 hours to machine and 3 hours to assemble. The FIRE engine needed less than 47 minutes to machine and just over an hour to put together. The factory used 80% automation. That was unheard of in the 1980s. The first car to use this engine was an Auto Bianchi Y10. It came out in 1985. Over time, the engine kept improving. It didn't get stuck in the past. In the year 2000, it arrived in Brazil with electronic fuel injection and an electronic accelerator. Later, Fiat added something called the multi-air system. This changed how the valves worked and made the engine smoother and more efficient. The Fire engine also became flexible. Some versions ran on both gasoline and ethanol. Others used compressed natural gas. One of them powered the Siena Tetrafuel. The engine quickly became a favorite in Brazil. It started in the Palio 1.3 16 valve. After that, it showed up in the Uno, the Siena, the Punto, and the Strada. People trusted it. It was easy to maintain. It was tough, and it lasted. That made it perfect for places where reliability and low costs were more important than fancy extras. Over the years, Fiat built more than 23 million Fire engines. That number tells its own story. It was used in small cars across the world and kept up with tougher emission rules as time went on. Even as car technology changed, the Fire stayed relevant. In 2023, Fiat finally ended production. That marked nearly 40 years of service. But its story didn't really end there. The newer Firefly engines carry on the name and the same goal: to be reliable, simple, and smart. The Fire engine helped Fiat grow in markets that needed strong, practical cars. It proved that innovation doesn't always mean complexity. Sometimes the best ideas are the ones that just keep working. In the early 1990s, European car makers faced a challenge. New rules pushed them to cut down on CO2 emissions. Petrol engines couldn't keep up with those demands, but diesel engines could. They used less fuel and gave more torque. That's when PSA Peugeot Citroën stepped forward with something new: HDI diesel engines. Peugeot had a long history with diesel. Their first diesel car came out in 1928, and they brought the Peugeot 504 diesel to Australia in 1978. But the real turning point came in 1998. That year, PSA joined forces with Ford to build a new line of diesel engines. The project was called Gemini. It became one of the most successful engine partnerships in the car industry. Production took place in several plants: Tremere and Douvrin in France, Ford's factory in Dagenham in the UK, and even Volvo's engine plant in Skövde, Sweden. What made these engines special was a system called common rail injection. Instead of pushing fuel into the engine the old way, this system stored it under high pressure in one shared pipe. From there, it sent exact amounts of fuel into each cylinder using electronic controls. The system also used something called pilot injection. It sprayed a small bit of fuel before the main burst. That small change made a big difference. It cut down on noise and vibration. It also helped the fuel burn more cleanly. PSA called these engines HDI, which stood for high pressure direct injection. They became known for strong pulling power. That came from using long-stroke engine designs and high compression. These engines didn't need to be revved hard to feel powerful. For example, the 2-litre HDI produced 320 Nm of torque. That's similar to what a 6-cylinder petrol engine would make. All HDI engines used turbochargers and intercoolers, so they stayed responsive even under load. But PSA didn't stop with performance. They also worked hard to make diesel engines cleaner. They added a system called FAP, which trapped and removed tiny particles from the exhaust. Later versions of the engine met Euro 6 standards, which meant they produced much lower levels of nitrogen oxides. These improvements also helped reduce CO2 emissions. And unlike some brands that saved these features for high-end models, PSA made sure they were available across the lineup. By 2007, PSA had built about 1.8 million cars with HDI engines. That was half of their total output that year. The engines came in several sizes. The most common were 1.6-litre and 2-litre, but there was also a 2.7-litre V6 twin-turbo used in larger or premium models. Through partnerships, PSA's HDI engines even made their way into cars from other brands. One example was Mini under BMW, which used PSA's 1.6-litre diesel in some models. For over a decade, HDI engines showed what modern diesels could do. They were strong, quiet, and efficient. They helped PSA stay ahead of emissions rules while giving drivers solid performance. In a time when fuel prices were rising and clean air laws were getting tougher, these engines offered a smart and practical solution. They didn't just meet the moment, they helped shape the future of diesel in Europe. Volkswagen didn't invent diesel engines, but it made them exciting. In 1989, The Audi 100 TDI rolled out with a brand new kind of diesel. It was the first to combine turbocharging with direct fuel injection. That engine had 5 cylinders and produced 118 horsepower. It also made 203 pound-per-foot of torque, which meant it pulled hard even at low speeds. Back then, diesel cars were known for being slow and loud. This one was different. It was smooth, quick, and surprisingly efficient. The real magic came from how it worked. Turbocharging used the engine's exhaust to spin a turbine that pushed more air into the engine. Direct injection meant fuel went straight into the combustion chamber, not into a separate pre-chamber like old diesels. The result was better power, cleaner burning, and lower fuel use. Most TDI engines also used intercoolers to cool the compressed air before it reached the cylinders. That helped improve performance even more. Volkswagen kept pushing. In 1999, they used a new kind of fuel system called Common Rail. This went into the Audi A8 V8 TDI. It allowed much more precise control of fuel delivery. Around 2000, VW moved to the Pumpe-Düse system, or unit injectors, which replaced the old distributor-style pumps. Then in 2003, they added piezoelectric injectors that reacted faster and gave even better control. They also introduced variable geometry turbochargers to cut down turbo lag. That made the engines feel even quicker without losing efficiency. In 2004, they tried out dual-stage turbocharging in partnership with BMW. By 2008, they were adding new emissions tools like lean nitrous oxide traps to meet rising environmental standards. This wasn't just happening on the street. TDI engines were winning on the track too. In 1998, BMW entered a diesel-powered 3 Series in the 24 Hours Nürburgring race. It ran on a 2-litre direct-injection diesel engine and used half as much fuel as the gasoline cars around it. And it won. That made people take notice. Then in 2006, Audi launched the R10 TDI. This was a Le Mans race car with a 5.5-litre V12 diesel. It made 638 horsepower and dominated endurance racing. From 2006 to 2014, Audi's TDI race cars ruled the LMP1 category. These wins weren't just for show. They proved that diesel could be powerful, reliable, and efficient all at once. As the tech improved, diesel's popularity exploded in Europe. In the early 1990s, diesel cars held about 17% of the market. But governments were pushing for lower CO2 emissions, especially after the 1997 Kyoto Protocol. Diesel engines produced less CO2 than gasoline, so tax incentives followed. That helped push diesel sales higher. By 2015, more than half of all new cars sold in Europe ran on diesel. In the UK alone, there were over 12 million diesel vehicles on the road by 2017. But all of that came crashing down in 2015. That was the year Dieselgate broke. Investigators found that Volkswagen had installed secret software in its TDI cars from 2009 to 2015. These programs could tell when a car was being tested for emissions. During the test, the engine would activate all of its emissions controls, but on the road, it turned them off. That let the cars perform better and burn less fuel, but it also meant they were releasing nitrogen oxides at levels far above legal limits. The scandal triggered lawsuits, fines, recalls, and a massive loss of public trust. TDI engines had helped make diesel popular by blending strong performance with great fuel economy. For more than 2 decades, they led the diesel revolution in Europe, but Volkswagen's decision to cheat emissions tests didn't just damage its own reputation, it helped bring the entire diesel movement to a halt. What started as a technical triumph ended in a global scandal, and the shadow of Dieselgate still hangs over diesel cars today. Meanwhile, we trusted German engineering, but the numbers say something else. Watch next to find out how Chinese cars are changing the game.